In the algebra course, quadratic equations were treated, and you know that quadratic equations, when plotted, give rise to parabolas. So this is an example, and this is another example of a parabola. So you can take any of these two forms. We're interested also in what happens to the left of the turning point and to the right of the turning point. Let's just note down this turning point. The x-coordinate of this turning point I'll call x asterisk. Well, let's just focus on the region to the left. So imagine I start at this point here, I'll call it A, and I move up to B, and I move up to C. Now, what you'll notice is as one moves from point A to B along the curve, so I started from this point A, point B is such that it has a larger x-coordinate. Remember, the x-coordinate increases as you move to the right. So if this is the x-coordinate of point A and this is the x-coordinate of point B, you know that the x-coordinate of point B is larger than the x-coordinate of point A. Similarly, if I just mark this as the y-coordinate of point A, as we move from A to B, we move from a point with a y-coordinate YA to another point with a y-coordinate which I'm going to label YB. The key thing here is the y-coordinate also increases. Remember, as you move in this upward direction along the vertical axis, the y-coordinates increase. So in moving from A to B, there's an increase in x and there's an increase in y. That means that the change in y is positive, is greater than 0, and the change in x is also greater than 0. So the change in y divided by the change in x is also greater than 0. Because the delta y is greater than 0, it's a positive number. So I'll just give you an example, like it could be plus, okay, let's assume that the change in y coordinate is an increase by 2 units, and the change in x is an increase by, let's say, 1 unit. dy dx is plus 2 over plus 1, which is 2, which is also positive. Hence why I have delta y divided by delta x being greater than 0. It means that the change in y divided by change in x is positive. If you move from point B to C along the curve as well, the same thing happens. The x coordinate increases and the y coordinate increases, because in moving from B to C, you're moving from, well, this x coordinate to this one. So you're moving in this direction to the right, which means you have an increase in x coordinate, so delta x is also greater than 0. And moving from B to C, you're moving upward, so the y coordinate also increases. So delta y divided by delta x is also greater than 0. So in summary, to the left of a maximum, the change in y, well, dy dx is greater than 0. That's the key thing you need to know. So to the left of a maximum, dy dx is greater than 0. And to the right of a maximum, if you notice, if I move from this point to this point, the x coordinate is increasing, because what's happening is I'm going from here to here. So I'm moving in this direction, so the x coordinate is increasing, but I'm moving downwards in the vertical direction. So the y coordinate decreases. So moving downwards in this direction. If I call this point D, and this point E, which is a different color, you can see that I'm moving from this y coordinate to this y coordinate. So the y coordinate decreases. So what happens to the right of the maximum is as follows. The change in y is negative because the y coordinate decreases, but the change in x is positive. So delta y divided by delta x is negative, is less than 0. I'll give you an example. Imagine delta y is a negative number. So let's say delta y is minus 3. So the y coordinate decreases by 3 units, and delta x increases by, let's say, 6 units. So pay attention to this negative sign. A negative change in y means the y coordinate decreases. So what you have is delta y or delta x being equal to minus 3 over 6, which means delta y, delta x is a negative number, minus 1 over 2. So delta y, delta x is less than 0. So the main point here is to the right of the maximum, dy dx is less than 0. To the left of a maximum, dy dx is greater than 0. All that means is to the left of a maximum, if you move along the curve, the y coordinate, well, let's put it this way. To the left of the maximum, if you move from a point towards the maximum, the y coordinate increases and the x coordinate increases. to the right of the maximum, if you move from the maximum, well, along the curve away from the maximum, you find that the y coordinate decreases, but the x coordinate increases. So here's the parabola, here's the maximum. To the left of the maximum, the change in y divided by the change in x is always greater than 0. And to the right of the maximum, the change in y divided by the change in x is always less than 0. One way to think of it is as follows. If I move from a point here towards the maximum, y will increase and x will increase. But also, if you move from the maximum in this direction, as long as you're in the left region, as y decreases, x also decreases. Think about it. If you move from this point here, which I'll call point B, to this point here, A, the y coordinate is decreasing and the x coordinate is decreasing. So I'll just show you something. There are two scenarios. You have a case where if you move from A to B, the y coordinate increases and the x coordinate increases. So you have a positive number divided by a positive number in terms of the change in y and change in x. So dy dx will be positive, which means it will be greater than 0. But if you're moving from B to A, the y coordinate decreases and the x coordinate decreases because you're moving to the left in terms of the x direction. So delta y, the change in y is negative and the change in x is also negative, which means that delta y divided by delta x is going to be a positive number. A negative number divided by a negative number is positive. So delta y dx is also greater than 0. So that's what this means. This represents dy, the change in y divided by change in x is always greater than 0 to the left of the maximum. So this point here is the maximum, the highest point of the curve. To the right of the maximum, the opposite happens. The change in y is always opposite to the change in x. If we move from this point C to this point D, from C to D, so in this direction, the x coordinate is increasing. If you think about it, the x coordinate is increasing, but the y coordinate is decreasing because we're moving downwards. X coordinate increases because we're moving to the right, but the y coordinate decreases because we're moving downwards. So in that case, delta y is negative, but delta x is positive. I know that a negative number divided by a positive number is a negative number. So delta y divided by delta x is less than 0. If you move from D to C, the x coordinate decreases because you're moving towards the left. Think about it. If you're moving from D to C, you've essentially moved towards the left, but you're moving upwards, so the y coordinate decreases. So in this case, delta y is positive because we're moving upwards, but delta x is negative. The change in x is negative, and a positive number divided by a negative number is a negative number. So to the right of the maximum, if you move along the curve in any direction, as long as you're within this right hand side region, dy dx is less than 0. To the left of the maximum, dy dx is always greater than 0. I'm now going to summarize what I just explained using what you've learned from the algebra course. You know that a line like this, so increasing from left to right, has a positive gradient, a positive slope. Remember, dy dx represents the gradient. And a line as follows has a negative slope. So a line which decreases as one moves from left to right has a negative slope. So if you consider this parabola, this point here, the highest point here, is the maximum, and you just pick any point on the left hand side. If you draw a tangent to that point, and if you determine the gradient of that tangent, you are determining the gradient of the point. You can see that for any point to the left hand side, every tangent you can draw will have a positive slope because it's of this form. But to the right hand side, consider any point. You draw a tangent to any point, you find that the tangent is such that it has a negative slope, is of this form, where if one moves from left to right, you're moving downwards. You move from left to right, you're moving downwards. So to the right of a maximum, dy dx is negative. There's a negative gradient. So the gradient at every point to the right of maximum is negative. To the left of the maximum, gradient of any point is greater than 0, and at the maximum, which is a stationary point, dy dx is 0. So the maximum dy dx is 0. And that just simply means, here's another parabola. The lowest point here is known as a minimum. So this is just revision from the algebra course. As you can see, if you draw a tangent to any point to the left of the minimum, it's such that it's of this form where the slope is negative. So to the left of the minimum, the gradient at any point is negative, it's less than 0. To the right though, the gradient, if you draw a tangent to any point, you find that it's such that the gradient of the tangent will be positive. The gradient of the tangent will be positive. So dy dx is greater than 0. The gradient at any point to the right of a minimum is positive, it's greater than 0. At the minimum, which is a stationary point, dy dx is equal to 0. So the gradient at the minimum is 0, the gradient at a maximum is 0. Given a quadratic equation, like the equation here, you need to be able to determine whether its stationary point, also known as the turning point, is a maximum or a minimum. From the algebra course, you know that the plot of a quadratic equation is always such that there will be either a maximum or a minimum. So given a quadratic equation, without even plotting, there's a technique for determining the nature of the stationary point. And that just simply refers to whether the stationary point of the quadratic function is a maximum or a minimum. So I'm going to show you the first technique, which is the sign test. You need to be able to determine the nature of the stationary point of a quadratic function without even plotting the graph of the function. Determining the nature of a stationary point simply refers to determining whether the stationary point is a maximum or a minimum. Now, as mentioned earlier, at a stationary point, dy dx is 0, and a maximum is a stationary point and a minimum is also a stationary point. So for this function, in order to determine the stationary point, we need to determine dy dx and then set dy dx to 0, and then we'll obtain the x coordinate of the stationary point. So for this function, dy dx is equal to, so the derivative of 3 over 2x squared is, well, 2 times 3 over 2, which is 3, times x to the power 2 minus 1, which is 1, so I'm not going to write the 1, then minus the derivative of 6x, which is 6. To determine the stationary point, we have to set dy dx to 0, so 0 is equal to 3x minus 6. At the stationary point, I'll just write this as start point, dy dx is equal to 0. So keep that in mind. So solving for x here gives 3x is equal to 6, x is equal to 2. So the x coordinate of the stationary point is 2, and that's all we need. So I'm just going to write that down here. This represents the stationary point. This column is going to contain information about what happens to the left of the stationary point, and the right hand side column here is going to contain information that refers to what happens to the right of the stationary point. So now what we've done is we've determined the x coordinate of the stationary point of this function. So I'm just going to pick an x coordinate of a point to the left, which for instance is 1. So 1 to the left of 2. Think about it, if you have an x-axis, if you have 2 somewhere here, an x coordinate to the left of 2 will be 1, and the x coordinate to the right of 2 will be 3. So I'm just going to pick 3. And what am I doing? Well, what I'm going to do here is just sketch a graph. So imagine this is a stationary point and the x coordinate is 2. I just want to pick a point to the left of the stationary point that lies on the curve. I've just picked one, and I can pick one here. This one is such that its x coordinate is 3. I'll just pick another one here, the one where its x coordinate is 1. So let's just assume the x coordinate of this point is 1. And then we want to determine the gradients on either side of the stationary point. So how do we do that? Well, we know that dy dx is 3x minus 6. And when x is 1, so to the left of the stationary point when x is 1, dy dx is 3 times 1 minus 6, which is 3 minus 6, which is minus 3. So the sign of dy dx is negative. So dy dx is less than 0. So I'll just write negative. At the stationary point, dy dx is 0. To the right of the stationary point, so this point here, x is 3, that's the point we chose. Well, the point we chose has an x-coordinate of 3. dy dx is 3x minus 6, so the sign of dy dx can be obtained by replacing x with 3, and that gives 3 times 3, 9 minus 6, which is 3. So dy dx is plus 3, a positive number, so it's positive. So the last just requires us to sketch the tangent to this point here with an x-coordinate of 1. Because the sign of dy dx is negative, the tangent is going to be a line with a negative slope. So a line like this. Because dy dx is positive, to the right of the stationary point, the tangent is going to be a line. Remember, a tangent is a line with a positive slope, so a line like this. And at the stationary point, a tangent to a stationary point is always a horizontal line. Even if the parabola looked like this, tangent to the stationary point here will always be a horizontal line. So that's what I'm going to draw here. So by doing this, we have an idea of the nature of the stationary point, because we know that we're going to have this shape. So think of combining these three lines to give this curve. We know that our quadratic equation actually looks something like this. It has a minimum as a stationary point. So the nature of the stationary point for this quadratic function is a minimum. That's the nature. And it occurs at the point where x is equal to 2. So the x coordinate of the minimum is 2. To determine the y coordinate of the minimum, all you have to do is go to the quadratic function and replace x with 2. And that gives 3 over 2 times 2 squared minus 6 times 2, which is 3 over 2 times 4, which is 3 times 2, which is 6. This is 6 minus 12, which gives minus 6. So this stationary point has an x coordinate of 2 and a y coordinate of minus 6. Now if you think about it, what this is telling us is if you plot this quadratic function, you get a curve, a parabola that looks like this with a minimum. This stationary point here is a minimum and it lies on the quadratic curve. That means that its coordinates must satisfy the equation of the curve. So given that we determine that the x coordinate of this point, which lies on the curve, that the minimum is 2, we determine that x coordinate is 2. To determine the y coordinate, all we have to do is replace x with 2 in the equation, and we'll get y is equal to minus 6. Remember, the point lies on the graph, well, on a curve, for instance, a quadratic curve, it must satisfy the quadratic equation. This has been dealt with in the algebra course. Here's another quadratic function. Our aim here is to determine the nature of the stationary point. We want to know whether when we plot the graph of this function, we'll get this parabola or a parabola of this form. So we want to know whether the stationary point is a maximum or a minimum without plotting the graph of this function. A technique for doing that is the sign test. So the first thing you need to do is determine the x coordinate of the stationary point of this function. So to do that, just find dy dx. For this function, dy dx is equal to minus 8x plus derivative of 2, which is 0. So derivative of minus 4x squared is minus 8x plus the derivative of 2 is 0. So dy dx is minus 8x. At the stationary point, dy dx is 0. So I'm going to set replace dy dx with 0. So 0 is equal to minus 8x plus 0. So 0 is equal to minus 8x. And that means that, well, if I divide both sides by 8, I get 0 divided by minus 8 is equal to x. So I get x is equal to 0. You know that 0 divided by any number is 0. So x is 0. So that's the x coordinate of the stationary point, which I'll write here. So this middle column here, so just focusing on this 3, middle column represents stationary point. The column to the immediate left contains information about points that lie to the left. Well, this right hand side column contains information about points that lie to the right of the stationary point. So we know that the x coordinate of the stationary point is 0. So the x coordinate of the point to the left of the stationary point will be, for example, minus 1. The x coordinate of a point that lies to the right of the stationary point, for example, will be 1. We know that dy dx is equal to minus 8x plus 0. So dy dx is equal to minus 8x. So when x is minus 1, What's dy dx? Dy dx is equal to minus 8 times minus 1, which is plus 8. So the sign of dy dx is positive. At the stationary point, you know that, well, gradients is 0, dy dx is 0. To the right of the stationary point, so this point 1, dy dx is equal to minus 8 times 1, which is minus 8, so a negative value for dy dx. And you know that, well, for the sketch of a tangent with a positive slope, so a tangent to any of these points, so this point, which lies to the left of the stationary point, a tangent to that point will look like this, positive sloping. A tangent to this point with an x-coordinate of 1, which lies to the right of the stationary point, will have a negative slope, look something like this. At the stationary point, you know that tangent is always a horizontal line. So what do we have? What we have here is let's combine the shapes. So this is essentially what we have. But you know, for a quadratic function, it's going to be a curve. So we have a maximum. This is the case we have a maximum. So the stationary point of this function is a maximum. And that's the sign test.